Alright, good morning. We are continuing with the applications of logarithmic and exponential functions. We have seen actually one example on 4.5 and 4.4, one example of exponential functions, one example of logarithmic functions, like earthquake scales, interest questions, interest problems are one. We're going to just see more variety of these questions, more particularly in this section. So we're starting 4.6, and let's take a look at one common example again. It's again exponential expression, but this time you are modeling US population. US population has been modeled by 310 times e to the small decimal value times t. T is time. And I believe 310 is the, what do you think 310 is? What's the US population in 2010? What do you estimate? Is it about 300 million people? So that 310, shortly they drop to 6 zeros because it's kind of waste of digits. This is the initial population in 2010, and you are predicting forward how much it's going to be 2011, how many people it's going to be 2030. So this is the rate the population is supposed to increase, but you're starting with 310 million, okay? But sometimes the question is flipped. They don't ask what happens after 50 years to become, what's the population is gonna be. They don't ask this 50 years. They said for planning purposes, like how many years does it take to become 350 million people? Sometimes they ask, they give you this side given, and this will be asked. So to perform this operation quickly, to get that number of years, you need to get t all by itself. So you can just substitute 350 million here and divide by 310 million and compute this time. So we may need to sometimes change our model, rewrite, replace, flip the location of the variables. In other words, solve for some certain variables such as time. Okay, and to be able to switch from switch places of variables, we may need to take logarithm of both sides, introduce logarithms. Okay. All right. So this is what's going on. This is one example of real life. Sometimes the need that you don't always want the model in the current form. You may need to switch it. Okay. So we are going to make two examples of this type of method, this type of trick. First one is a formula used in chemistry. Are there any chemistry majors here? No? Any chemistry related majors maybe? No? You? Okay. You'll probably see this in your chemistry course. N is equal to N0, initial amount of whatever N is, okay? It's probably a chemical, okay? Amount of initial chemical amount times e to the negative 0.25 t, okay? We want to solve for t here. Okay, solve means, I want to replace solve with another word. What is the meaning of solve again? If you want to replace, find an alternative word for it, what would you pick? What would you say? Starts with I. Isolate. Yeah. Solve for means you need to isolate t in one side, and preferably we prefer the left side. You need to get t all by itself. And just look at what you have around t. I have a number on the side t is. I have an exponential. And not only exponential, I have a number right beside t. All these three items should go. I must have only t on this side and bunch of other stuff travel to the other side. Okay, so we will do what I promised here, one by one, starting with the term which is the furthest away from t. So which term here can be got rid of easily first? Which one? We have 1, 2, 3. Pick one of them out of 3. And 0. And sub 0 is the first. Okay? The one that's further away is this guy. And I want to get rid of, so how can I get rid of n0 from this side and get it to the other side? Divide. So we will divide both sides by n0. And we have n over n sub 0 equals e to the negative 0.025 t. Okay, how can I get rid of this negative 0.025 or e? This is called an exponential form. This is exponential, right? E is a number 2.7 blah blah blah. So I need to get this exponential form, get rid of this exponential form, and I want to see t on the ground all by itself. How can I do that? What's the right method or weapon, tool to reduce exponentials to just something on the ground? What? Logarithmic function, yeah. They kinda get rid of each other. Logarithm and exponential functions are opposite of each other, inverse of each other. So you need to take logarithm of both sides, log. However, what particular base makes most sense here? We need e, right? Base e, so these two can match and cancel. But we call log e a shortcut, short name. It's ln, yeah. So ln is used, and this will take care of ln e. It just drops out. Because we know that the second rule of logarithms, when the bases match, that logarithm is 1, and the power just, this power exponent falls to the ground level. So ln of n over n0 equals negative 0.025 t. Okay, next. Remember, our purpose is to get t all by itself. So what do I do next? Divide. Okay? Alright, so t is ln n over n0 negative 0.025. I want to move this negative to in front here. And I know another trick. If there is a decimal value in the denominator, you can write this more properly. 0.025 is actually, this thing is actually 25 over 1000, right? Because it has 3 digits, so you have 3 0 after 1. This is 25 over 1000. So you have a ratio in the denominator. If you have a ratio in the denominator, there is a way to reduce this. You take the numerator, and what do I do with this denominator? Now minus goes in front. What do I do with 25 over 1000? How do I divide? This is divide by another fraction. This is called complex fraction. Come on, anyone? You have some stuff, but you have a fraction here. What do you do? How do you move this up and combine with this stuff? Yeah. We flip 25 over 1000 as 25, 1000 over 25 and multiply. But wait a second, isn't 1000 over 25 a whole number? When you flip it, it turns into a whole number, which is 40. So you have 40 times minus 40 times ln of n over n0. This is better. Okay, so this is kind of initial answer, raw answer, but we need to fully reduce it and make it look better. This is the best answer. Okay, any questions? What was it, n over n0? Oh, didn't work. Now let's restart. I need to get ln and then a fraction, right? All right. Good. All right, we have a similar one coming up. Again, a chemistry question. You probably hear this word a lot, pH level. pH level of the soil, pH level of the water. It has to be in certain numbers so it can be safe for the plant or for you to drink, okay? So that pH level is actually computed by this formula, a logarithm formula. But there are actually two variables here. So whatever this H plus means, I don't know, I'm not a chemist, so that is taken, that measurement is taken, and you compute its logarithm. By the way, this logarithm doesn't have any base, that means its base is 10, right? It's a common logarithm. So you need to get this H exposed. They want it to be isolated. Isolate H plus. I need to get rid of this, I need to get rid of that. H plus must be single thing left out. Okay? So what can we do? How do you get rid of, which one is first? Are you going to attack logarithm quickly or negative first? Why don't we multiply both sides with a negative? This turns into plus, this turns into minus first. I don't know why they use the bracket. You can use a parenthesis. I mean, mathematically, it doesn't make sense to me. But it must be a chemistry thing. All right, next, we need to get rid of a logarithm. What's the antidote for logarithm? What's the cure? That logarithm, when they combine with logarithm, it's going to wipe it off. No? If you want to get rid of any logarithm, you need to turn it into exponential form. So you need to do this circle, box, and triangle reformulation, replacement. Remember back in the first week of logarithms? If you want a logarithm gone, you need to either flip these box, circle, triangle triplets and get things in exponential. Okay? So anyone? Any volunteer for this? Base is the new base. We always start with the base. What is the base? 10. All you need to do is set it into a number and raise it into power. That's it. You actually have two options. Which one is H plus? H plus is the right side. Which one is pH then? This one. You don't have an option. Minus pH though, because this thing has a minus. Alright, that's it. You found what H plus is. Okay, this is method 1. The second method, another way to cancel a logarithm is, any ideas do you have? Do you have any ideas? Raise both sides to the power of a special base. So put a base here, whatever base you choose, here a base. Raise both sides into the same, into the power of same base. So minus pH, you put minus pH to a base, logarithm to a base. Alright, here's the question. What base are you gonna choose so that logarithm and that thing can cancel? Is it E? Is it 5? Is it 2? Do you have a choice? No, it's 10. Yes, this is 10. So you need to go with 10 here. Now look what's going on. If you have a logarithm and base 10, they cancel out. Cancel, cancel. And this guy falls to ground. Look what you got again. H plus is 10 to the minus pH. This is the second method. Same thing, right? This is the second method. Trust me, there's a third way. There's a third way you can make if you don't like neither of these. So what is our problem again? pH equals logarithm H plus. The third method is, if you want to get rid of a logarithm, you need to get a logarithm on this side as well and cross them out. Question is, how do I turn this into logarithm of base 10? Logarithm of base 10. How? Can I just put pH under this logarithm? Are these two things equal? They are not equal. So what do I need to? You put this on top of 10, so these two can cancel and they are equal. Okay? Now once I put those on top of 10, we can now cancel these. H plus again, not log, 10 minus pH. Okay? Make sense? Alright, we're starting into real applications. Right now we were just playing with models or equations that has already been built for us. Okay? How do you build your own equations or models? We're not technically gonna do it. They will always supply something to start with, so you're gonna manipulate them, but there are actually basically two models when using exponential expressions. One is growth. We already mentioned these in the past, though they are not new. The other one is exponential decay. In exponential equations, you have either growth and decay. If you are working on a model in your majors that is growing in a rate, then you must, like this picture, always growing, like your investments, your bacteria in your sample, okay, or population sometimes, then you must use an equation y equals initial population, rate, and time. There are three concepts here. So the final population or final amount of money or final amount of your whatever your material is, always initial amount, initial times e to the rate and time. Okay, this is growth if rate is positive. If you see a positive number on the exponent, your population, your money, your material is growing, getting bigger and bigger. Haven't we seen this formula in other terms as A equals PERT? Where did you see this? This formula has been observed before. Where? What concept? What model? Well, continuous compounding in interest banking questions, right? In interest PERT, but it's the same. Initial, E, rate, time. They just went with name change, letter change. Letters change, but the equations serve the same purpose. Okay, if this number is negative, then your material population is decaying, getting less and less. Okay? The first two questions actually, not the first two, first question here was that kind. Whatever this n is, probably n is the short for what? What material? No, you don't know? What? Nitrogen. Nitrogen, yes. N is in nitrogen. Nitrogen levels are decreasing. Why is it decreasing? Decaying, getting less and less, because this is negative. After 10 minutes or 10 years, you're measuring what the new nitrogen level is, whatever, wherever you're measuring this. Okay. So again, when your rate is negative, your picture is going down, getting less and less over time. And if your K level is positive, small number, 0.06, but positive, you see some increase over time. All right? Any questions? All right. Our first question is again interest questions, but this time it's a different approach. It's not a regular interest question. And for wherever we've seen this, I don't know the section number, but we always computed the final amount of money you have in your bank in a rate and in the initial deposit. This time, what's given in this question is you're investing a certain amount over 30 years, and you know the final. This is new. We always ask this one. At this time, you're not asked this. You are given that. So what is the question then? What do you think they can ask? In an continuous interest compounding, there are four concepts, or there are four variables, A, P, or T. They usually give you the three on the right side and ask you what A is. This time A is given. I know my final amount. Initial number invested is given. And how long this money is kept in this account is given. T is given. So what is asked? Rate is not given. This is asked. there should be always one variable missing. Out of 4 things, 4 will be given, R is asked. Okay? Alright, let's first substitute all these given items and find out rate. What is the average rate? Approximately, you're going to round it into the nearest 10 of a percent. 173, 387, 0.62 is final quantity. A. P is 25,000. E is a fixed constant. R is unknown. What is T? 30. Okay, first, what is the first thing we're going to do here? Yes, we divide by 25,000. We need to get rid of this number first. Alright, these questions actually, and the remaining questions all depend on heavy calculator usage. So take out your calculators if you wish and help me with this. E to the 30R. By the way, I'm going to flip the location of these. I like always numbers first, variables next. Is, what is this thing? It's
6.81550.
6 point, come again?
81550.
Okay. Just take 8. Just take several, 4 or 5 digits to make sure, to be certain. Because if you cut it too much, like 6.8, you may not get the exact precision of the answer. Alright, next I need to get this 30R alone on the ground, so I need to get rid of this exponential. We will put ln to both sides to cancel e, right? Alright, somebody compute this. Let me continue here. This is ln of 6, 8. No, don't compute that yet, because we are going to divide it by 30R. These two cancel, remember? And 30R on the base. Just compute this divided by 30 and it will be R, which will be anyone?
0.06397.
Okay, yeah, that's fine, because we want it to be, we want to first change this into percent. So what is this in percentage? Just move this 2 units to the right. It's 6.390%. Is it? 6.39. And they want how much? Nearest tenth. So you want to round this number so you can get nearest tenth. They want this. So 39 is going to be rounded into 4, right? 6.4%. Okay? Right? So let's try this. Alright, next part is how long will it take to this money to reach at $250,000. So this time the question is flipped. Look, always start with marking what's given here. This time we already know the rate. We computed rate. We already know how much initial money is, 25,000, and we already know the target. Target is gonna be $250,000. What we don't know is, as it's clear from the title, first two words, how long? How long? So this is the question mark. We need to get the T. So substitute everything back in place. So we want our money to grow into $250,000, not 170, 250 more. So I believe it's gonna take more than 30 years, because 30 years, after 30 years, your money becomes 170. You want it to be 250, probably it's gonna take 40 years something. Initial money is 25,000. R is this amount, 0.064. Always change it into decimal. And T is unknown. We are looking for red T. Oh, I forgot some digits. 25,000. Okay. So first step is again the same. Get rid of that 25,000 in front. And that's nice, because 25,000 goes into 250,000 as how many times? 10. Same steps over and over. We take ln of both sides and divide by 0.064. Okay, now all you need is a calculator. Punch the keys. 36, exactly 36. No, you must have some digits, right?
It was 35.98.
Okay, 35.98, but you rounded into the whole years because it says round to one decimal place. So when you round to one decimal place up to this decimal, then you round 8 to up, and this becomes 10, so it becomes 36. Yeah. I told you it's more than 30 years, so it's 36 years. Alright, so far so good. Okay, this is nice. This is a population estimation question. Somebody compared populations of Thailand and Ethiopia in 2000 and 2010, after 10 years, over 10-year period. Thailand grew from 61.4 to 68, and Ethiopia is 65.3 to 70. Okay? And population is again growing, as you see. So we have a growing model. Initial EKT. K is going to be positive. So they want us to first find in part A, by the way, this is K. They want us to find what rate each population of each country is rising. What rate? You're going to find two K values. One K for Thailand, the other one for Ethiopia. Okay? Make sure what's exactly asked. Oh, this one. In part 1, they want us to fill out these two boxes with P0, E, K, and T. You need to find K and substitute in this formula. Alright? So you're gonna give us P0 and K. T will be unknown because we don't know how long we wanna measure it. Alright. Let's start here. First, let's do Thailand. How do I find K? Any ideas what to do here? Any suggestions? Let me read some details. This model is formed, okay, starting in 2000. So we already know on the left side what the initial money you deposited in the bank. Let me turn this into bank. You have 61.4 million when in 2000. And 10 years later, your money grew into 68. Let's put this into the formula. Again, P equals P0 e to the kt. I'm looking for K, okay? And what is P0 here? What's the initial population of Thailand you first took before you building this equation? What is the initial measurement money you put in bank for Thailand? It's 61.4. Do we know already after certain years what P grew into? Okay, by the way, here is my idea. What is the question here? They are looking for K, right? We are looking for K. This is unknown you're solving for. You need to find out T, P0, and P. Substitute a value for them so you can solve for K. That's what I'm going for. I'm using this table to make P0, P, and T and find out K. So I found P0, the initial measurement for this model is 61.4. Do we know final measurement this population grew into? Which is? I don't know K, but how many years did it take the population from 61 to jump into 68? It's 10. There you go. Go solve this equation. Okay, I will do it quickly because I already seen a pattern. I must always divide the both sides by the initial number, take ln, and divide by the number in front of the variable. Look, let's copy it. Let's copy. Take 68, divide by 61.4, take ln. No, I need more space here. I will do it here. Again, K will be, look, here is the pattern. We take ln of the 68 divided by 61.4. You always take this number divide into 68. And then finally you divide the number next to K with the whole thing. This is it. Again, slow motion, this is what I did. 61.4. And then these are gone. I took ln. And these two cancelled. And I divided by 10 so I can get K alone. That's what we have done in this question twice. Here and there. I just did it fast forward. So K is this number, but you need to round it into 5 decimal places. Anyone? 58 over 61.4. And I divide this by 10, right? Is that right? No, it's 61.4. Point 0.0102 up to how many decimals? 5 decimal places. 0.01021. I round this up. So the formula is P0 61.4 E raised to the K is 0.02021 T. 1021. Am I right? Okay, we need to get the second one before we check answer, otherwise it's gonna say incorrect if you don't put nothing. Let's get the same thing to Ethiopia. Okay, but I already know the initial value, 65.3 e to the something kt. All we need to do is find out k by the same formula. Now I'm gonna do the same thing for Ethiopia. I'm gonna do it here. What is the final quantity? 70. What is initial? 65.3. Right? E k over 10 years. And I know k will be, divide these two numbers first and take ln of them. 70 over 65.3 and divide the number next to 10, next to k. Seventy 65 over 3. Am I right? 0.0969. Well, when it becomes 5, do we round up or round down? Up, so it becomes 10 or 70. 0.0070. Am I right? You don't need that extra zero actually. Right? Did you get the same answer?
It says round 5 decimal places. And in that case, you would round 5.
Oh, 1, 2, 3, 5. Okay, that's already been rounded. Okay, so we need 69.5. Thanks. So I rounded into 4. Alright, any objections before we check? I hope we have more than one shot.
The first one is still 4 decimals.
Yeah, I was right. Whew. Look, 1, 2, 3, 4, 5, 21.
Oh, okay.
5 decimals. Good, good. Now you have your models. We will put it into work. Population of Thailand in 2020 means 10 more years later. In other words, 20 years from the initial date. when you first took the measurement in 2000, 20 years later, what will it be? So you're gonna take this formula and make t to be what? What t are you gonna make? This 61.4 is in 2000. 20. So you need to substitute 20 and just multiply this out, really. Import b here. It's going to be, its p is asked. P0 is 61.4. I'm doing Thailand first. Thailand. This is Thailand. 61.4. E, what is the rate we found? 0.01. 021, and time is 20. All you need to do is punch in these numbers and compute me up to nearest 100,000, because this is millions. So really type in 61,400,000 so you can get up to 1,000 an answer. Anyone? Or do you want me to do it? So that's 61.4. I will make it 61.400. 61,400,000 e to the 0.01021 times 20 years. Hope I'm right. I got all the numbers. 10, 21, 20, 75,396,309. What's the nearest? What nearest? 1,000. So I need to stop here. This is 1,000. 9,716. Nearest 1,000 is 10,000. So when I up this, it becomes 9,700. Becomes 10,000. So it's 75,310,000. All right. Oh no, it says million. Nearest. It has already million, so you need to turn this into decimal. Sorry. So I will cut off this into millions. 75.31. 70, right? This was 31, and I rounded out. 71, 31, 75.31. Am I right? Million, because they already have the word million here. You can't put zeros. This is the rounding work I am doing here. I rounded this into 10,000 because 9,700 is 10,000, and then turn this into million. 75.31. So I took these two. 75.31. Okay. All right. The next one we will do Ethiopia. You will use this and plug in 20. Do you have an answer already? Just take these and make T20. 75.04. Are you sure?
That's right. It's 75.037.
Okay. Makes sense. Why Ethiopia isn't more than Thailand? Although Ethiopia has more population in 2010, Thailand passed it in 2020. Look, 75.31 is more than Thailand beat it, Ethiopia, because Look how slow Ethiopia grew. 65 to 70 is slower than 61 to 68. So rate, look at the rate. Rate is here. 0.01 is the growth rate of Thailand. 0.06 is the growth rate of Ethiopia. I can compare them right here. That's why Ethiopia is less. Thailand would have more because growth rate, not the initial population. Initial population, Ethiopia is more, but the growth rate is greater for Thailand than for Ethiopia. Okay, I hope these numbers right, or you're in trouble, Madison. Oh, hold on, we need to first check because there is an incorrect. It's your fault. No, maybe the first one is wrong. So we need to type these in again.
Wait, it says round the nearest 100,000.
Oh, nearest 100,000 is this first digit, right? So it would be 75 million then. This one will be 75, right? Good, thanks. So you fix your mistake. And mine as well, okay. And this one only 75. No. I'm making a mistake. Yeah, this will be 3. And this one, what was it? 0.03. So I will round this down to 0, right? This one is fine. Correct? No? 100,000 is the first digit. 75,300,000, this one.
Yeah, that would be 0. I'm just wondering if it's because it already says million, if it's actually talking about the 100,000 decimals.
No, before million, we round off. Forget million. Okay, what is our... Here, let's do this again.
Could you click show me example and see?
Look, 75,309,000. When I round this, it becomes 300,000, right? 300,000. Then since it says million, I need to take 6 zeros off. And 75.3. Let's read again. Round to the nearest 100,000. They mean the population, not the hundreds or stuff, okay? Let's check again. Yeah, this time we're good. Alright, how long does it take to make 100 million for Thailand and 100 million for Ethiopia? Again, here is your models. You take this. This time you have given left, but not given time. You're gonna find out the time. So let's do this the proper way. First we start with Thailand. And what is their formula? PT is 61.4 e to the 0.01020 t. What is given? We want it to be 100 million. I put 100 here. Already 61.4 is fixed. Rate is the same. But we don't know the t. So how do I find the t? Shortcut. We divide 100 by 61 over 4. Take ln and divide the whole thing by 0.01021. This is the work I'm gonna do. Let's take a calculator. Ln O 61.4, no, 100 divided by 61. 100 divided by 61.4 and divide whole thing by 0.01021. Okay, let's make sure we take this in parentheses so I know that number divides the whole top. 47.77 years. Does it make sense? Yes, because in 20 years, how much did they grew? They grew into, in 20 years they were 75. Of course it's gonna take more than 40 years to make 100. Okay, what is the precision amount? They say just year, in the year, so we want to go with whole year. So what is the whole year amount? 47.77. We round it to the whole year, it's gonna make 48. This is 48, right? But hold on, is it 2048 or 47? Now this is a tricky question. 47 or 48? In what year it's gonna hit that 100 million year? It will take, I know, 47 years and 77% of a year, so we will still be in 2047, right? We won't be hitting the next year, correct? So we need to round down. This is a tricky question. So I will take 47 here because we will still be in 2047. Okay, how about this one? Ethiopia. Take its formula. PT is 60, what? 65.3 e to the 0.0695t, right? I just need to set this 100 on this side. T will be same work, ln of 100 divided by 65.3. rate is a little less. All we need to change here is, this is 65.3, rate is less 695. Am I right? Yep, thank you. Should be more than 6 years, definitely 61 year. So in 2061, and 3 months later, probably 3 months later, you're gonna hit that number in 2061 March something. Alright, so let's try. In year 2061. It's gonna take it longer for Ethiopia because their rate is slow. Correct? Okay, are you excited? I hope you're right. Yep, we're good. So we don't always round up. Just try to make sense, okay? Sometimes it's asking for a year, so you round down. Because the year is not complete until you hit 100%. Okay, this was a fun exercise, right? But yeah, it's a lot of calculations. And since it wants perfect, correct answer, you need to go really slow and checking back for mistakes. Okay? Alright, we're starting a different subject. Going back to chemistry again. No, it's not. No, we're skipping this one. Oh, because yeah, we've done enough of this one, right? Isn't it almost the same as this one? It's the same as this question. Almost the same. You're gonna solve for t here, and you're gonna solve for t, and how long it's gonna take. It's a population question as well, but it's the only difference is this time you have a negative. It says how many years does it take to drop 22% of the carbon? Okay. You want me to set it up? At least set up that equation and you can get the numbers on your own. Here's the question again. There is already a model for you. Q after t years is some initial Q. E negative because this radiocarbon is getting less and less, that it has a half-life. It's becoming less every moment, and that rate is 0.0000121 T. They say there is, let's say, 1 pound of carbon right now. How long does it take it to drop into 22% of the current rate? 22% of the current rate. Okay? How long? How old is the sample? Round to the nearest here. Do not round intermediate calculations. Yes, do not round intermediate calculations. Get the final one. We're gonna find out how many years is it old. It's old. So final amount is gonna be 22% of current one. So what do you think? How do I compute that final amount? Do we know how much we have right now? Do we know this current amount? Oh, yeah, the current remaining part is 20, no, this is not current, percent of the initial amount. Millions years ago, there was an initial amount here. Current one, this is current one. Current one is 22, only 22% of the initial left. Yeah, sorry. So can I say this Q is 0.22 of Q0 right now? Can I substitute it with this? Can I? Right? So Q is 0.22 of the past amount. Current one is 0.22 of the past. So I just substituted that. Guess what's gonna happen now? You divide both sides by Q0 and they cancel. You have 0.22 e to the minus 0.0000121 t. All you need to do is take logarithm of both sides and divide by the rate. Okay? And this is it. And round it to the nearest year. It says do not round the intermediate. Compute all this at once. Some people compute this ln2 first and divide by this. It's not a good idea, okay? Just take ln and divide by that. So what number did you get? Anyone? Anyways, you can get it on your own. I just want to finish this one off. Can we? Maybe we should leave it the next time. Yeah, it has 6 bars. I don't think I can finish today. So why don't we stop here today? We'll continue this on Monday.